In order to add our API operations, we will need to introduce a controller, specifically a Web API controller. The controller groups the set of actions that can handle the API requests, including the routes, authorization, and a series of other rules usually needed in REST APIs. So to start, let's go to our controllers folder here, right-click, new file, and the name that we're going to give to this controller is items controller, since this is going to be the controller that's going to be managing our catalog items. So let's go ahead and collapse our navigation pane so that we have more space for looking at the code. Let's start by defining a namespace. The namespace catalog service controllers. Okay, and now let's define our class. It's going to be items controller. And so each of your Web API controllers should derive from controller base. And I'm going to import the missing namespace by doing control dot using Microsoft ASP.NET Core MVC. So you always want to derive from controller base, not from controller, but controller base, because this provides many properties and methods useful when handling HTTP requests, like the bad request, not found, and created at action methods, which we will be using in this and in future lessons. Now, you should always also add to each of your controllers the API controller attribute, so API controller. This attribute enables a series of features that improve your REST API developer experience, like for instance having model validation errors automatically return a 400 bad request error, or how to bind incoming requests into our method parameters. The other attribute that you want to add here is the route attribute. This one specifies the URL pattern that this controller will map to. For instance, if we use items here, that means that this controller will handle the routes that start with /items. So for instance, if we get, let's say, I'll just add a little comment here. So we have localhost 5001, and if somebody navigates into items, that means that since the route specifies items here, that means that items controller is the controller that's going to handle that specific route. Okay, so I'll remove this. And you can also use route for the different operations that we're going to define in this controller. You can specify your own routes, but for now, this is going to be our root route for all the operations in this controller. Now, since in this lesson we would like to focus on the REST API part of the microservice, we will not be interacting with a real database just yet. We will use an in-memory list of items that our API operations will interact with. And in a future lesson, we will introduce a proper repository class that will take care of interacting with our database. So let's start by defining this static list. So I'll declare private static read-only. We'll make this list read-only because we will only allow to construct it, to create it or instantiate it during controller construction time. And after that, there will be no need to modify the instance of this list. So it's going to be list of item DTO, because this is going to be the list that we're going to be returning when somebody requests the items from our REST API. So we want to specify the contract that we already defined for our items here. So item DTO, and then it's going to be named items equals new. And so let's see, we're missing some more namespaces here. Okay, so I'll do control dot again, system collections generic, and we also need our play catalog service DTO's namespace. So let's define our first item here. So I'll just define it inline here. So new item DTO. For the ID, we'll just generate a random GUID. So new GUID. May need another namespace import. Yep. And for the name, let's name this one Potion. The description is going to be restores a small amount of HP. The price is going to be, let's say, 5. And for the created date, let's just do datetime of set.UTC now. Okay, it's going to be the current time in UTC time. So let's add, I'll just copy this to add 2 more items. The second one is going to be, let's say, an antidote. So the antidote cures poison. Price is going to be, let's say, 7. Created date is UTC now. And the last item is going to be, let's say, a brown sword. And it deals a small amount of damage. It's going to be a bit pricier, let's say 20. And yeah, UTC now, colon, save. Okay. Also notice that we're using a static list here. So we do this so that the list does not get recreated every time somebody invokes one of our REST API methods, right? Otherwise, the list will be recreated every single time that a method is invoked, which we don't want. So now let's define our first operation. This is going to be the operation that's invoked anytime somebody tries to get all the items that we have in the REST API. So we're going to say public IEnumerable of item DTO get. And so yes, we're returning a list of item DTO. Now, each of your API operations should be marked with the correct HTTP verb, right? Since this is going to be responding to the get verb, we should mark this with the HTTP get attribute. And then for this method, really it's super simple. We only need to return the current list of items, right? So we just return items. So that's our first get operation. The next one is going to allow us to return one specific item. So we'll name it public item DTO get by ID. Okay, and then we're receiving the specific ID as a GUID. And just like we did before, we need to decorate this with the HTTP get attribute. But here we also need to specify what part of the route that the user specifies is going to map to that ID. So in this case, we do that by specifying ID here. Okay, so that means that if somebody comes with, and I'll put it here, so somebody does a get, it's a little comment here, does a get into our items route, and then they specify some ID like 1, 2, 3, 4, 5. That 1, 2, 3, 4, 5 is captured as the ID in the HTTP get route, and that's mapped into the ID parameter over here. Okay, so the route would look more like, in a more generic case, it's going to be /items/ID. And so to do this, the only thing that we have to do is just find the correct item in our list. So we'll say var item equals items where, and for this I'll need control.system.link. So for each item, we will do item.id should match the ID that we got in the parameter. And then we will say, okay, so let's find the only item that should match with that ID, get that one. Otherwise, I mean, with single default, we can say either get the item or just return null in this case. And then we return that item. Okay, so that's what we need for our get routes. So let's try them out, see how that goes. So I'll hit F5, my keyboard, to start the web server. That opens the browser. And let's now navigate to our Swagger page. So /Swagger. And here you can see that we have our two first API operations defined, items and items by ID. And we also have the schema of our item DTO showing up here, right? So if you expand this one, we can see the shape of our item DTO right there. So if I expand the items route, you can see a little example here of what it would return and expected return for a successful case. And then if you want to try it out, you just have to click on try it out. Then you click on execute. And here you can see the request URL that was invoked into our API /items. And then you can see the response body here along with the status code 200. And the response body has the 3 items that we have in our static list. So that's working fine. And let's say that we want to try the other operation where we have to specify an ID. So I'll just copy the ID of one of these. I'll collapse this for a moment. I'll expand the other one. So this one expects an ID as parameter. So I'll do try it out. I'll paste the ID here, and then I'll click on execute. And just as before, it will go ahead and use the items route, but it will append the ID of the item. And as you can see, we got a 200 OK, and we got in the body, we got the actual the body of the item that it was retrieved. Okay, so that's working fine. So let's now add a method for creating an item. So I'll minimize this, stop debugging, and then I'll close the terminal. Okay, so to create items, we're going to be using the post HTTP verb, and let's create a method for that. So it's going to be public action result. Now the action result type, so this one allows us to return a type that represents one of the several HTTP status codes, like 200 OK or 400 bad request. But it also allows us to return a more specific type, like a DTO type if we need to. So we can return different types depending on what we have available. So let's see how we're going to be using this. So action result of type item DTO. And this is going to be named, let's just name it post for now. And then here is where we're going to receive our create item DTO contract, right? So that in that way we enforce that whoever calls this API has to follow our contract for creating items. So create item DTO. And this one has to use also the correct HTTP verb. It's going to be HTTP post. And then for creating an item, we will just create it inline here. So I'll just say var item equals new item DTO. And we'll assign a random ID here, just like we did with the list. You do it. And then we will say for the name, we'll say create item DTO.name. For the description, that description. For the price, create DTO.price, and for the create date, again, datetime offset UTC now. So that's the item, and now that we got it, we will just say items.add to add the item to our static list. Finally, we're going to return the type created add action, which is derived from action result. So this is going to be used to say, hey, so the item has been created and you can find it at the following route. Which route is going to be it? Well, it's the route with the name. So name of get by ID. So this means that the caller will be able to find, we're going to produce a header in the response that includes the exact route of the item as provided by the get by ID operation over there. We will also provide the ID of the created item as an anonymous type here. So it's going to be ID equals item.id. And lastly, the actual body of the response, which is the entire item. All right, so that's ready. I'll do F5 so we can try that out, see how that goes. Okay, back here, I'll just close this one. So back into the previous tab, I'll do F5. As you can see, now we have the post operation listed here and the create item DTO listed at the bottom. So I'll go for post, I'll expand this, and to try it out, I'll do try it out. And so here's where we can create a new item, right? So let's figure out some new item to create here. Let's say we're going to create a high potion. And so this one is going to restore a medium, restores a medium amount of HP. And the price is going to be, let's say, 9. Okay, and so now I'll do execute. As you can see, it invokes the same route, but in this case it was with a post verb. Post. And yeah, so we got 201, which means created at route, created at. Here's a response body, so the entire created item, including the auto-generated ID over here. And here you can see the headers includes the location of the just created item. So if I wanted, I can grab this ID and I can collapse, let's collapse post, and then expand get items by ID, try it out, and I can paste that ID here, and I should be able to find that just created item. As you can see, over here is the high potion. So post is working just fine. So now let's say that we want to update an item. So that's where we need to introduce the put operation. So let's go back to our Visual Studio Code. I'll stop this and close terminal. And let's declare a method to update items. So for this time, for this one, I'm going to declare public iActionResult, and I'll be using iActionResult because in this case, we don't really need a specific type for the return. We will just return this one called no content, meaning that's what you usually do for a put operation. You don't want to return anybody. You just say, hey, yeah, I did my job, but there's nothing to return. So it's going to be named put. So we want to receive the ID of the item to update, and we will use the update item DTO contract to receive the new payload or the new information for this existing item. So update item DTO. And we also have to specify the proper verb, so HTTP put. And just like we did with the get by ID, we have to specify what part of the route is going to be used for the ID parameter. So just like before, it's going to be ID. Okay, so once again, when somebody comes with something similar with get items by ID, somebody comes with not get, but put items / ID and somebody, then this is the operation that's going to be honoring that route. So how do we implement this? So the first thing that we want to do is probably find the item that we're going to be updating. So what I'll do is I'll just say the existing item is going to be from our items list. Items list where item.id is the ID that we distributed the parameter, and then again singular default, right? So if you have it, we'll find it right there. Now that we found the item, we're going to update it, and to update it, we're actually going to do at this point is just clone it into a new item with the updated values. So we will say updated item is going to be the existing item with the name that is going to be update item DTO dot name, description update item DTO dot description, and price update item DTO price. Okay, so that creates a clone of the existing item and into updated item, and that's the one that we're going to be updating into the list. Okay, so now what we'll do is we're going to find the place in the list that that has the item that we need to update. So to do that, we're going to say, so the index of that item is going to be in the list, find index, okay, so it's going to be existing item.id equals ID. Okay, so that finds the index on that list where the item is, and then now that we have the index, we're going to say item.index equals updated item, replaces that in the list, and then we'll, like I said, we will just return no content. There's nothing to return. Okay, so let's try this out. So I'll do F5 once again, start the web host, And yeah, I'll close this page, and then I'll just refresh our Swagger UI page. And as you can see, now we have our put operation here at the bottom, and all the way to the bottom, we also have our update item DTO specified. So I'll expand put. This is going to require us first the ID of the item to update. So to get an ID, I'll actually execute our get items route. So I'll try it out, execute, and let's say we're going to update our antidote. So I'll copy the ID of the antidote, collapse this, and then back in input, I'll say try it out. I'll put the ID here, and then let's grab a few of the properties of the antidote. So we don't have to start from scratch there. Collapse this, and then I'll place those items here, remove this comma, and then let's say we want to update just the price, and we'll say that the price, the antidote is going to be, let's say 9. And I'll go ahead and do execute. And as you can see, in this time, it invokes the API with the put verb into this request URL that includes the ID of the item. We get a 204 result, meaning no content. So as you can see, there's nothing being returned here, but the item was certainly updated. And we can confirm that by grabbing the ID of the item once again and going to our get items by ID route. We can try it out, paste it there, I'll execute, and then you can see now we have the antidote with price 9. So the update operation succeeded. So finally, let's add the operation to delete an item. So let's minimize this once again, stop and close. And before adding our delete route, just for completeness, let me add the comment here for our HTTP post route, which I didn't do. The post route is going to, as we saw, responds to the post verb, and the route is going to be like just items, right? So just so we have that comment over there. Now for the delete route, we're going to be using a method that is also be returning a action result, just like in the put case, because we're going to be returning no content here also, and it's going to be delete, and we're going to receive, the only thing that we need to receive here is the ID of the item to delete, and we also have to respond to the HTTP delete verb. And again, just like we did with put, we have to specify which part of the route we're going to be using for the ID of the item to delete. So that's going to be ID once again. And here, just like we did with update, we need to find the index of the item to delete. So I'll copy that line from put, copy that into here. Okay. And so once we found the index of the item to delete, we're going to say, okay, so from the list, remove at, and we'll say index. So that removes the item at that index location, and then we will just return no content. So again, for completeness, let's add a little comment here. So when somebody comes with the delete verb and says /items and then /some ID, this is the method that's going to be honoring that deletion. So to try it out, again, I'll do F5. Okay, so back in Swagger UI, I'll refresh the page. And as you can see, now we have our delete route, our delete operation showing up here. And so I'll expand that. So we need an ID to delete. So let's actually execute our get items route, try it out, execute, so we can pick something to delete. Let's actually delete this antidote once again. So let's copy the ID of the antidote. And so I'll go back to delete, try it out, I'll paste that ID, and then I'll hit execute. And as you can see, now we're using the delete verb, invoking the API with delete. Here's the URL of the item that needs to be deleted. And we got a 204, no content. So as you can see, there's nothing returned, but the item should have been deleted. So if I go, I'll collapse this and I'll go back again to our get items route. I'll do execute again. And as you can see, the item, the antidote item has been removed. It's not here. So delete succeeded. So yes, our REST API seems to be working just fine. However, you can try querying for an item that that does not exist, an existing item, or perhaps creating an item that does not have a name. What will happen in that case? So we'll need to do something about those situations. In the next lesson, we will see how to properly handle these kinds of invalid inputs. Let's try a few of the unexpected scenarios that our microservice REST API could face from time to time. So I have our catalog project open here, and I'll just do F5 to start a web server and go to our Swagger UI page. So here we are in the browser. I'll go to Swagger. And let's start by getting the full list of items as we have them right now. So I'll open our get items operation, try it out, click on execute. And here are the 3 items that we have available right now. So let's say I want to query for one of these items, the potion. So I'll copy the ID of the potion, I'll close this, and then I'll actually go to our get items by ID operation. Okay, so I'll do try it out, I'll paste the ID here, but I'm actually going to flip one of the characters here. I'll flip this 1 to 2, so this is an existing item, we don't have that available, and I'll click on execute. See what we get. So what we're getting is a 204 result, right? Which is not expected. When an item is not found in the REST API, the expectation is that you would return 404 status code or not found. So let's see what's actually happening back in Visual Studio Code. See where we're getting this. So I'll put a breakpoint in over here in our get by ID operation. And then I'll go back to Swagger. I'll try this again. So I'll hit execute. And here we are, Visual Studio Code. So we try to find the item, and of course the item is null. We cannot find it. Okay. So what can we do about this? Let's see. I'll just stop debugging here, close terminal. And so really the fix is fairly straightforward here. What we would like to do is just check that if the item is null, we will go ahead and return not the item, but we would like to return the not found action result. However, of course, IntelliSense is complaining here because not found does not convert into ItemDTO here, right? So here's where action result becomes super useful. Now we can say action result of ItemDTO, and that gives us the ability to return either the item over here or the not found result over here in this case. So as you can see, we can return more than one type of result depending on the current situation. So let's try that out. I'll hit F5 once again. I'll remove this breakpoint first, and then I'll hit F5. Okay. So here we are again. I'll just copy this ID and refresh the entire page. Should still be a not found item. So get items by ID. I'll click on try it out. I'll paste that ID here, and I'll hit on execute. See what we get. So as expected, this time we get a 404 result saying not found. So this is the correct status code for an item that cannot be found in the REST API. And likely we're going to have the same issue with our put API, right? So let's see actually which APIs will be impacted. So not post, but put is going to be impacted because it needs to find the item. And likely the delete operation could also be impacted because it needs to, again, find the item before it can delete it. So let's start by fixing put. It's going to be pretty similar. Basically, if existing item is null, we will say not found. Okay, so that will do it for put. And then in the case of delete, what we're going to do is just that if index is less than 0, so basically a negative number, it means that we cannot find the index of the item. Therefore, we have to say return not found. Okay, so that should do it. I'll hit F5, let's see what we get. I'll close this, and I will I'll copy this ID, unexisting ID once again, and I'll try to do a put operation now. So I'll try it out. I'll put this ID here, and I'll put just something here for the body. So some item description, and price too. So just to try it out. And so I'll go ahead and say execute, and as expected, now we can get a 404 on that case. Not found. I'll take that ID once again, and let's try out our delete operation. So let's try to delete that unexisting item, see what happens. So yep, as expected, delete is also returning a 404. So we can now say that we're probably handling the case of not finding items in our different REST API operations. Now let's try something actually different. So what happens if we try to create an item with some missing item properties, right? So let me collapse this and collapse this, and then let's go to post. Okay, so I'll try to post an item, let's say without a name. We shouldn't be allowed, really. And let's say that this was really for our high potion, which the description would be restores a medium amount of HP, and that price was 5, right? Perhaps 7. And so let's try to create an item with no name. So go ahead and hit execute, go down, and 201, meaning create that action, so it actually got created. But look at this, the name is null. And if we try to query for that item with this ID, so let's do get by ID, try to query for it, execute. As you can see, the item is now in our collection and is with a null name. And not only that, let's see what happens if we try to create it with a negative number, right? So not 7, but let's say -7. What happens in that case? So let's do execute, and again it got created to 201, and then now we have this other ID, and so now this item actually has a null name and a negative price. So this is really bad. So what can we do about this situation? Let's go back to Visual Studio Code. Let's stop and close, and then I'll expand our navigation pane again. So what we can do is actually do some model validation, right? So back to the DTOs, we need to introduce a couple of attributes to properly validate the inputs here. And the DTOs that we would care about in this case are both the create and the update DTOs. So what we can do is, let's say for the case of the name, if the name is always required, what we can say is just add this attribute here called required, which might require a namespace import, system component model data annotations import, and that makes it so that name will always be required anytime somebody uses this create item DTO. Okay, and I'll also add it for our name property in the update item DTO. And then also I'll do we can do something about the price. So in the case of the price, let's say that, well, let's add an attribute here, and let's say that what we want to enforce is that the price should always be, let's say, between 0 and 1000 GIL, right? Let's say, but we actually want to allow free items, so they can be 0, but definitely not negative, and only up to 1000. So what we can do is use a range attribute here, and we can say here the minimum value, which is going to be 0, and the maximum value, let's say, is going to be 1000 here. Okay, so that makes it so that anytime somebody specifies a price here, it has to be in this range. That implicitly also makes sure that it cannot be null, right? But however, I mean, since this is a value type decimal, really this value can never be null. So worst case, it will be 0. But with this, we ensure that it has to be between 0 and 1000. I'll do the same thing for our update item DTO. Hit save. And now let's try it again. So I'll hit F5. Okay, back here. And I'll go ahead and I'll just copy this and I'll refresh our page. So let's go ahead and try to do a post. Try it out. And so let's start first with no name. So I'll say price is still positive, but we don't have a name. And let's try to execute this and see what happens. So as you can see this time, we do get a 400 bad request error, which is expected in this case. And we do have the proper validation message coming out of the errors, this errors array that is available now. So one or more validation errors occurred, status 400, and the name field is required. So that's great. And furthermore, if we still want to use that negative number, so I'll do -7, hit execute. See, now both validations have been performed. So the name field is required, and the field price must be between 0 and 1000. You can also try using invalid input for our put API operation now, and you should get similar validation errors. In the next module, we will learn about the repository pattern, and we will stand up a proper database to store our catalog items. In this module, we will update our catalog microservice to be able to store and query for items that live outside of the service and into a proper database. By the end of this module, you will have a solid understanding of the following: what is and how to use a repository pattern to store and query data, how to use a MongoDB database as the underlying data store of catalog items, how to use Docker to run infrastructure services like MongoDB Server, what is and how to use the dependency injection technique for proper decoupling of dependencies, and how to use the .NET configuration system to specify settings that could change across environments. In terms of our overall system design, in this module we will keep working heavily on our catalog microservice, but we will also stand up the MongoDB server that will hold the database where we will store the catalog items. Let's get started. In this lesson, we will learn about the repository pattern and how to implement a repository to manage the catalog service items in a MongoDB database. So, what is a repository? A repository is an abstraction between the data layer and the business layer of an application. To understand why you may want to use a repository, let's say that today we have the application logic of our service talking directly to our MongoDB database. However, a few months or years from now, requirements change and we need to switch to a different database provider. Given the way that things have been set up, we would likely need to rewrite a good chunk of our application logic in order to talk to the new database, which is pretty bad. Instead, what we can do is introduce a repository. This repository is the only one that knows how to talk initially to our MongoDB database, and it's the only one that our application logic will interface with. Then, if we ever get the requirement to move to another database, the only thing that we would need to change is our repository, but the application logic stays the same. So, the repository pattern is important because it decouples the application logic from the data layer and minimizes duplicate data access logic across our service. We will be using MongoDB as our database of choice for all the microservices in this course. MongoDB is a document-oriented NoSQL database which stores data in a JSON-like documents with dynamic schema. We will prefer a NoSQL solution as opposed to a relational database for our microservices because we won't need relationships across the data because each microservice manages its own database. We don't need ACID guarantees, where ACID stands for atomicity, consistency, isolation, and durability, which are properties of database transactions that we don't need in our services. We won't need to write complex queries, since most of our service queries will be able to find everything they need in a single document type. And we need low latency, high availability, and high scalability, which are classic features of NoSQL databases. Let's go ahead and implement our items repository. Before implementing our repository, we will need to decide which is going to be the class that represents the objects that will be managed by the repository and that will make their way into our database. The class that we use for this should not be confused with our DTOs because we want to have the freedom of updating how we store the items in the database at any given point, regardless of the contract that we will need to honor with our service clients. We will then give the name of entities to the classes that our repository uses. So let's start by adding a directory to store these entities. So right click on Play Catalog Service, let's add a new folder. Let's call this one Entities. And inside Entities, let's add a new file. And our main entity here is going to be the catalog items. So let's just call this one item.cs. And here, let's go ahead and declare our namespace. It's going to be namespace entities. And now let's declare the class. All right, so our item entity is going to have a GUID, which is going to be the ID. And let me control dot to import the system namespace. It's going to need a name. It also needs a description. We also need a price. And finally, we are going to need a datetime offset that's going to be the created date. Okay, so now it's time to actually add a repository. But before doing that, we're going to need a NuGet package, the MongoDB driver NuGet package, because this is the one that's going to allow us to actually interface with the MongoDB database. So to do that, I'm going to do Ctrl-J in my keyboard to open the terminal. And I'm going to switch to the directory where we have the catalog service. So that would be the catalog service. And so then I'll just do .NET add package MongoDB.driver. So this will bring in a bunch of libraries that we're going to be using for interacting with MongoDB. So, and you can confirm that the package was added if you click on Play Catalog Service, csproc, you'll see that we have that new library right here. Okay, so now let me just close this terminal. And now we can actually create a directory for our repository. So I'll right click, Play Catalog Service, new folder, repositories. And in this folder, I'll create a new file. Again, since this repository is going to be managing our catalog items, I'll name it items repository. Yes. And at this point, I'll just close this navigation pane so we get more space. Let's add a namespace. It's going to be repositories. And the name, like we said, public class items repository. Okay, in order to be able to interact with MongoDB, we're going to need a few class level variables here. The first thing that we're going to define is actually a constant. We're going to name it collection name. Collection name. Which is going to be, the value is going to be just items. So the collection name represents the group, a collection represents a group of objects in MongoDB. Similar to as in a relational database, you will have a table. In MongoDB, you have a collection. Okay, so the collection that we're going to store all these items in MongoDB is going to be named items in our case. Now we're going to define the variable that's going to hold the actual instance of this MongoDB collection. So let's name this one read-only Mongo collection of item DB collection. Okay, so I'm going to need to start importing namespaces here. So Control dot to import MongoDB.driver and Control dot to import Play Catalog Service entities. Like I said, DB collection is the object that represents our actual MongoDB collection. We'll add one more class level variable here to represent the filter builder that we're going to be using to build the filters to query for items in MongoDB. So let's declare a filter definition builder of type item. Let's name it filter builder. And we can get that from builders of item dot filter. Now that we have that, we can go ahead and declare the constructor of this repository. So public items repository. And here what we want to get is to actually construct the instance for DB collection. But before we can do that, we have to start by using the Mongo client class, which is the one that you can use to actually connect to the database. Here's where you declare how you're going to connect to MongoDB. So we're going to say Mongo client equals new Mongo client. And here's where we can specify the connection string to connect to MongoDB. For now, we'll just declare this connection string right here in plain text. But later on, we'll move this connection string to a more suitable place. So it's going to be MongoDB localhost 27017. Also, in a future lesson, we will learn how to actually stand up that MongoDB server so that it actually lives in localhost 27017. Now we're going to declare the object that represents the database, the actual database where these catalog items are going to live. So database equals Mongo client get database. And then the name that we're going to give to this database, since this is the catalog microservice, the name is going to be just catalog. Finally, we can get an instance for DB collection. And we can do that by doing database that get collection of item, and then we give it the collection name that we have already declared. Okay, we'll be using this DB collection object for a few operations in a moment. Now, for the repository public methods, we will be using the asynchronous programming model. This will avoid performance bottlenecks and enhance the overall responsiveness of our service. To take advantage of this model, all of our methods will become asynchronous by returning async task and by using the await keyword anytime they interact with the database. We will also use the async suffix on all the methods to surface the fact that the methods are asynchronous. Okay, so the first method that we're going to implement is the one that's going to be able to return all the items in the database. So let's name this one public async task of I read only collection of item get all async. Okay, so I'm missing a namespace here. So like I said, we need to return task to make this method async. And I'm also using iRead-only collection here because really the expectation from the point of view of the consumer is that we're going to provide a collection of items that the consumer should not need to modify. So this is a collection that should only be read, right? So this is a good API pattern to follow. How to await this collection of items? So basically we can do return await DB collection, then we can do find, the find operation. And here, since we are not going to really provide any filter because we want all the items, we can just say filter builder.empty to list async, to convert that list into an asynchronous list. And then, yeah, that will give us all the items in the database. Okay, so let's now declare a method that we can use to get one specific item from the database. So I'm going to declare public async, again, task of item in this case. I will name this method getAsync. It's going to receive a GUID. It's going to be the ID of the item, and I'm going to import the system namespace for this. Okay, let's scroll down a bit. And then to be able to query for this item, we need to create a filter. So I'm going to declare a filter definition of type item. So let's name it filter. And then we're going to use the filter builder to say that we want to build an equality-based filter, where we're going to receive this entity object, where the entity.id should match the ID of the parameter that we just received. Okay, so that's how you can build a filter to find one of the items based on ID. And then we can just say return await db collection find. Then we provide the filter, and we'll say we want to get the first item that we find. So we're going to use first or default async in this case. So that will find the first item in that collection that matches that filter. Let's now add a method to be able to create an item into the database. So to do that, we can define public async task, create async, receive our item that we're calling it an entity here. And the first thing we're going to do is a quick check to make sure that that receive parameter is not null. So if entity is null, we're just going to throw an exception, argument null exception, and we're going to name and give the name of our entity parameter. Okay, and then to create the actual item is as easy as saying await db collection insert one async, and then we provide the entity. Right, so that will go ahead and create the item into the database. The next method we're going to implement is the one to update an item, existing item into the database. So to do that, I'm going to declare public async task update async. Notice that both create and update are not returning really anything. So the expectation is that we either just insert or update the item, but we're not going to return anything back to the client. Here we're going to receive the item to update. Let's call it entity. That's the item to update. All right. And just like we did with create, let's do a quick check, make sure that we're not getting a null value here. And now we're going to build our filter definition to be able to find that item. And I'm going to copy the one from getAsync just because it's a very similar filter. The only difference here is going to be that we're going to rename this parameter here to existing entity, just to not confuse with the entity that we're going to use to find the ID. So we're going to say we need to find the existing entity whose ID matches the entity that we received, that ID. So that's a filter to find the existing item. And then we can go ahead and say await db collection dot replace one async. We pass the filter and we pass the entity that has to replace the existing item found by that filter. And finally, let's implement the method to delete an item from the database. So we're going to say public async task. It's going to be remove async. We provide the ID of the item to delete. Again, we're going to use a filter very similar to the one we use for get async. So I'm going to copy that one once again. So copy that. That finds the item. And then we can say await db collection, delete one async, and we pass the filter. Yep, that should go ahead and delete the item from the database. And with that, our items repository is ready. So in the next lesson, we will integrate it with our existing items controller so that it can start querying items from MongoDB. It is time to integrate our new items repository with our existing items controller. But before we can do that, we're going to need a way to translate our new item entities into our existing item DTO, specifically for the purposes of returning these DTOs in our get operations in the REST API. So there's a few ways to do this, but one simple way that we can achieve this is by introducing an extension method. So let's see how to do this. We're going to right click on play catalog service, and we're going to add a new file that we're going to name extensions.cs. Let's add a namespace here. Namespace play catalog service. And here we're going to declare a class that we're going to name just extensions. And in this one, we declare a public static method that returns itDTO. And this is because all extension methods should be static. And we're going to name it as DTO. So this method is going to receive a current instance of an item entity. Okay, and then let's import namespace control dot play catalog service DTOs and play catalog service entities. Okay, so the purpose is to just turn the item entity into the item DTO. And to do that, we just have to do return new item DTO. And we're going to provide here the different parameters, right? Everything comes from the entity. So item ID, item.name, item description, item.price, and item.created_date. Okay, so as you can see, it's a very simple method that just turns an item into an item DTO. We'll see how we use this in our controller. So now let's open up that controller. So in controllers, items controller, and I'm going to close the navigation pane once again to have more space. And the first thing that we're going to do is to actually get rid of this list. We don't need it anymore. And we're going to replace it with a variable for our repository. So it's going to be private, again, read only because we don't want it to be modified after construction. Items repository. And we're just going to say new. So it's going to get constructed. When the controller gets constructed, I'm going to import the right namespace here. So let's start using this items repository here. However, since you remember all of the methods in items repository are asynchronous methods, we will also have to turn all the methods in this controller into asynchronous methods. That way we can have the asynchronous benefits all the way from the controller all the way to the repository and to MongoDB. So to do that, I'm going to turn, let's start with get all. So we're going to turn this into async task of IEnumerable of item DTO. And we're going to append the async suffix to this method. Let's import a missing namespace, 3 tasks. And now to return the items, well, this is what we can do. Items is going to be wait items repository, get all async. Okay, and then from that, we're going to project these items into these item entities into DTOs. But before we can do that, we have to put this into parentheses. And then we can say, okay, so from that, let's do select. And each of the item entities is going to be turned into a DTO via our new asDTO extension method. So that's there you can see how easy it makes it this extension method to turn an existing entity into a DTO. And then we just return those items. Okay, so let's go to the next method. So this is get by ID. So once again, we will turn it into async task of action result of item DTO. Get item get by ID async. And then to get the item, what we're going to do now is just wait items repository get async, and we provide the ID. And at the end of this method, we can't just return that item entity. We have to say as DTO, so that turns the entity into a DTO. Let's now go for the post method. Let's scroll down a little bit. So once again, this has to be an async task of action result of item DTO, and it's going to be post async task. So instead of doing this, we're going to create an item entity, in this case, out of the properties of create item DTO. So we're going to say var item equals new item. And we're going to start giving it the properties values. So create item DTO.name, description, and create a date, here's where we're going to give the current date as the creation date of this item. Also remember, this is not item DTO, this is just item. Okay, I may need a namespace here. Yeah, the entities namespace. Now we can go ahead and actually create the item via our items repository dot create async method, and then we pass the item. And finally, we have to rename this method from getById to the new name, which is getById async, the one that we just renamed, because that's where the created add action should point to. Let's now go ahead and implement our put method. Scroll down. So once again, we turn this into public async task of iActionResult, put async. And once again, we have to do things a little bit different now. So I'm going to actually remove this whole block here. And first thing we're going to do is find the item now in the via the repository. So it's going to be existing item. We're going to see it's going to be await item repository that get async. Notice also how easy it is to actually interface with MongoDB via our item repository without having to write the same piece of code once and again, right? And the filters and all that. So we just got the item just like that. And then, yeah, if we cannot find the item in the database, in which case it will return null, we want to keep returning not found, just like before. And here, once we find the item, we will have to just update these properties based on update item DTO. So that's going to be existing item.name equals update item DTO.name, existing item.description, update item DTO.description, and existing item.price, update item DTO.price. And with that, we can go ahead and say await item repository update async with the existing item. And finally, let's go ahead and update our delete method. So we're going to say again async task iActionResult delete async. And we're going to do a similar logic to find the item as we just did with update. So I may just copy this piece here. Okay, I'm actually going to remove all this, paste that. Okay, I'm going to say, so yeah, so var item is item repository get async. If the item is null, we'll say not found. And otherwise, we can go ahead and say await item repository dot remove async with item.id. And then one last thing that we may want to tackle here, since we are making these changes, is to actually fix an issue, kind of a breaking change that happened in ASP.NET Core 3, where if you try to do, let me go back to post. If you try to do a post and create an action into a method that ends with async, with an async suffix, that's actually not going to work, because at runtime, ASP.NET Core is going to remove the async suffix from the method, and that will make it so that created action will not be able to redirect to the right place or to produce the headers that it needs to produce. And so there's an easy fix for that. So let's actually make that fix right away. So I'm going to go back to Explorer, going to open Startup, and let's locate the section where we do add controllers. In configure services, in add controllers, we're just going to add a little option here. So it's going to say options, and then we open and close braces, and we're going to say options that suppress async suffix in action names is going to be false. And with that, at runtime, ASP.NET Core is not going to remove the async suffix from any of our methods, and that will make post async work just fine. So our REST API is ready to use our new item repository to store and query the items in the MongoDB database. However, we still don't have an actual MongoDB database or even a MongoDB server. But that's a problem that we can easily solve via Docker. In the next lesson, we will learn about Docker and how we can use it to run the infrastructure components needed by our microservices. In this lesson, we'll learn about Docker and how it can be used to run infrastructure components needed by your microservices. So what is Docker? Docker is a platform that provides the ability to package and run an application in a loosely isolated environment called a container. Here's how it works. We start with our catalog service, which, as we know, needs a database to store and query for items. The piece of software that knows how to stand up and operate this database, in our case, is MongoDB. The MongoDB server, along with all the software prerequisites, has already been packaged in what we call a Docker image. And this image is publicly available in a place called Docker Hub. We want to download and run this image in our box. And to do that, we use the Docker Engine, which is one of the pieces that you installed at the start of this module. All Docker images are guaranteed to run anywhere the Docker Engine is available. To pull and run this image, we will use the Docker run instruction in our box. Once the image is run or executed, it becomes what is known as a Docker container, a MongoDB container in this case. This is a fully working MongoDB server ready to respond to the requests of our catalog microservice. The catalog service will create a database via the MongoDB container and will start interacting with it via the MongoDB driver for .NET. Notice that even when this container manages the catalog database, the database itself does not live inside the container, but outside of it, to ensure that it is not deleted once the container is destroyed. Let's try it out. To start using Docker in my box, I'll start by opening a terminal. So I'll press Ctrl J, and then I'll also close our navigation pane, just so we have a bit more space. And the first thing that I'll do is I'll just type docker run to run a container, and then I'll specify the -d modifier so that we don't keep being attached to the Docker process all the time. And then I'll do --rm, so this we'll use so that whenever we stop running the container, it gets automatically deleted so that we don't keep hanging it around in the box. Next, I'll specify a name, which is going to be just Mongo. So you can put any name here, but the idea is that you don't lose track of this Docker container, because otherwise you get a random name and it's a bit hard to identify. Next, we have to specify a port. So we have to specify which is the port that we're going to be using to talk to MongoDB, to the MongoDB server. So we'll specify -p 27017 map to 27017. So this means that in order for us to reach the MongoDB container, we can use port 27017, is the external port. And then in order to get that mapped into the internal MongoDB server, we have to map into 27017 also. So this port is the default port that MongoDB uses internally. And this just means that from the outside, we open kind of a window in order to talk to the container via 27017, and then that can be mapped into the internal port where MongoDB is already listening. You could be using any port in the left side. It's really up to you. We're just choosing a default mapping there. Then we'll specify a volume. The volume we're going to be using so that we specify how we are going to store the database files that MongoDB is going to be using. So we're going to say MongoDB data :data/db. So this section on the right side of the column /data/db is the default location where MongoDB stores the database files. So this mapping means that anytime that the MongoDB server tries to store files inside the container under /data/db, those files are actually not going to be written inside the container, but outside of the container into this location called MongoDB data, which is part of our local host machine. So it's outside of the container. So this is the way that we can prevent those database files from being deleted anytime the Docker container gets also deleted. And finally, we'll specify the name of the Docker image that we want to run. In this case is Mongo. Now I'll hit enter. Now perhaps I'll expand this a little bit more. So at this time, Docker is pulling all the layers of the MongoDB Docker image into my box. Okay, so layer by layer, it gets unloaded just the first time, and this may take a while. But the second time that you do this, and any subsequent time, this is going to be much faster because the image is already there. So if I did that again, it will run instantly. Then we can confirm that the Docker image is actually executing by just running docker ps. As you can see, the Docker image is up and running. It's been running for 14 seconds right now. Okay, so now we can try running our REST API against this Docker container and see how that goes. So I'll hit F5 here. And I'll go to our Swagger page. And so the first thing that we can try, just to verify that there's nothing here because it's a brand new database, is our get all items operation. So I'll try it out. I'll hit execute. And as you can see, there's nothing in there. The database is all empty. So next, let's try creating something. So I'll go to our post operation, try it out, and let's try to create something here. So we will go back to our potion sample. So I'll just name this potion, and this is going to restore a small amount of HP, and the price is going to be 5. And with that, I'll hit execute. And as you can see, the item has been created. We got a 201 response code, create that action, here's a response body, and we also got the location here to find our item. So in fact, we can copy this ID of this item, and we should be able to use our get by ID operation to find it. So I'll collapse this, I'll expand get items by ID, I'll try it out, paste the item here, execute, and certainly we can find the item. So the item has been stored into the database. But now, if you wanted to know how this item has been stored into the MongoDB database, there's an easy way to figure that out. So I'll go back to Visual Studio Code, and then I'll just stop and close this. And what you can do is use a MongoDB extension for Visual Studio Code. So to install that, just go to the Extensions hub on the left side, look for MongoDB, and it should be the first hit on the left side. So I'll click on that, I'll click on install. And now there's a new icon showing up on the left side for MongoDB, which I'll click now. And then it should connect straightforwardly into the MongoDB database just by expanding this node for localhost 27017, since it's the default port. It just connected. So I'll expand this. And as you can see, there's a catalog database available right there. So it has been created. If I expand that, there is an items collection available. This is the one that where we are storing our items. And then I'll expand that further. And as you can see, there is one document already created into the catalog database. If we expand that, we can see that there's an item in there. However, if we try clicking on it, let's click on it. What you can see most of the members of the created item, but some of them are not easy to recognize. Like for instance, the ID is not the GUI that we were expecting, and the created date is a bit hard to read. The other elements are there, so potion, description, and price. So how can we get a better, a more friendly, representation of these items like ID and created date? So ideally we want to see something more easily recognizable. So there's actually an easy way to fix this. Let's go back to our Explorer and let's go to our startup class. Okay, once again, I'll collapse this. So to fix the JSON representation of our items, we just need to register a couple of MongoDB serializers. We can do this in the configure services method of the startup class. We will talk more about the role of startup in ASP.NET Core Apps in the next lesson, but for now, let's just think of configure services as the place where we register services that can be used across the entire application. So let's scroll down a little bit. Here we are in configure services. And what I'm going to do is just expand this a bit, and I'm going to add Bison serializer. And for this, I may need to import namespace, MongoDB.bison.serialization, .register serializer. And here we're going to provide the serializer we want to use. In this case, it's going to be new GUID serializer. And then I'll import MongoDB Bison serialization serializers. And then it's going to be Bison type. And I'll import one more namespace. string. Okay, so that means that anytime we store any document into MongoDB with a GUID type, it will be stored actually as a string, as opposed to the representation that we were looking at a moment ago. And we're going to do pretty much the same thing for the datetime offset. So in this case, we're going to say, so instead of GUID serializer, we'll use datetime offset serializer. And then this line now says that anytime we store any document with a datetime offset property, it should be stored, that property should be stored as a string. Okay, so save that, and that should be enough to fix our representation of the items in there. However, to not mix things, what I'll do now is I'll actually delete our existing database so that we can recreate it with the proper serialization type. So I'll close this here, and I'll go back to our MongoDB extension, and I'll right-click in the catalog database. I'll say drop database. I'll type the name, enter, and if we refresh this, there should be no database available anymore. Okay, so with that, let's hit F5 once again. Okay, back in Swagger UI. Let's see if we still have the post available here. Yes, we have. So I'll just refresh the page, and I'll go back to post. And once again, we should have no items. So I'll go to get all items, try it out, execute. So there's no items because a new database has just been created, because we deleted the previous one. So back into post, I'll try it out, and I'll paste the what we typed a moment ago. So it's a potion, price 5, restore a small amount of HP, and I'll hit execute. And once again, the item has been created with this ID. And this time we'll go back to Visual Studio Code, and let's see how that got stored. So I'll refresh this, right click, refresh, expand catalog, items, documents. And as you can see, the ID, it already looks like a GUID. And if I click on it, and I'll close this a bit, now we have a much friendly representation of the item. The ID is a proper GUID, and the created date is a datetime offset that we can actually understand. So that's the effect of using these serializers in there. So let's continue using our REST API. Let's make sure all the operations are working properly. So as we saw, we just created this item. And if we use get items by ID, we should be able to find it. So let's confirm that. Paste in there, execute. So yeah, indeed, we were able to find the item. Now let's try an update on an item. So to do that, let's use the put API. So I'll click and expand on this. I'll say try it out. Let's grab actually the ID of that item once again. So it's over here. Here's the ID. So I'll paste it here. So we're going to update that potion. And then for the elements of this potion, let's copy also a few of the existing elements. So I'll copy this from our get by ID route into here. Actually, inside there, I'll remove this extra comma. And so the only thing we're going to modify here is just the price of the potion. So instead of being 5, I'll say it's going to be price 7. And I'll hit execute. We're at 204, so no content, successful no content. So this means that the item has been updated. And to confirm that, let's go back again into our get by ID route. Let's execute again. And as you can see, the price has been updated. So our put route is working just fine. And for the final exercise, let's try to delete this potion, right? So I'll go ahead and copy again the ID of the potion. And let's collapse this and that. And let's go to the delete route. Try it out. Paste here. I'll hit execute. 204, no content. And it's a success. So the item should no longer be there. So I'll try to actually get this item by ID once again. Let's see what happens. As expected, it's 404. It can't find the item. And in fact, if we go to get all items, there's nothing there. So the item was deleted. Okay, so at this point, we have a fully working REST API with all the basic CRUD operations that's working against a MongoDB database. But we still need to polish a little bit the code base that we have so far. So in the next lesson, we will learn about the dependency injection technique and the .NET configuration system. In this lesson, we will learn about the dependency injection technique and the .NET configuration system. What is dependency injection? To understand what dependency injection is, we can start by thinking about a class that uses some other class. For instance, our items controller uses the items repository. When you have this relationship where one class uses another class, we say that this second class is a dependency of the first class. Now, if instead of constructing the items repository object directly as we are doing so far, we receive an instance of items repository in the items controller constructor, then we are injecting items repository into items controller. This is what we call dependency injection. But also notice that the constructor is not exactly receiving an instance of items repository, but instead it receives an interface called iItems repository. This relates to what we call the dependency inversion principle. The dependency inversion principle states that code should depend on abstractions as opposed to concrete implementations. Let's bring again our class and one of its dependencies, dependency A. Currently, the class depends directly on dependency A. However, we can change this so that the class instead depends on an abstraction, which in the case of C# is an interface. And then we can have the dependency depend on or implement the interface. Why would we do this? Well, by doing this, our class implementation is decoupled from the dependency implementation in such a way that if we ever decide to switch to a different or updated dependency, our class does not need to change at all. The only thing that the dependencies need to do is to implement the interface that our class depends on. So, by having our code depend upon abstractions, we are decoupling implementations from each other. And this also makes our code cleaner, easier to modify, and easier to reuse. Now that our code is decoupled from these dependencies, we have a new problem. How and who is going to construct the dependencies? Imagine once again that we have our class, which depends on an interface implemented by dependency A. Since our class cannot construct the dependency directly, because it only knows about the interface, a third actor comes into play, which is called the service container, which in ASP.NET Core is known as iService Provider. During application startup, which typically happens in startup.cs in ASP.NET Core apps, we would register our dependencies with the service container, and this one in turn builds a map of all the registered dependencies. Then, eventually, when our class needs to get constructed, the service container first finds, constructs the dependency, or reuses it if it already has been constructed, and then injects it into our class as it creates our class instance. This is very powerful because you could even have dependencies that depend on other dependencies, but as long as they all have been registered with the service container, they will all be resolved properly whenever any class needs them during the application lifecycle. Let's also talk about configuration. At this point, our service is able to talk to our MongoDB database via the host and port information that have been hard-coded in our service implementation. However, this is not ideal, since eventually the MongoDB Docker container will live outside of our local box, where localhost will likely not make sense and port 27017 is not guaranteed to be available. Luckily, ASP.NET Core supports a few configuration sources that are able to store and provide such configuration details to our service when needed. One of the most popular sources, especially for local development, is the appsettings.json file, where we can store all sorts of configuration information that we expect could change across environments, like the database host and port. And the good thing is that, just like this one, there are several other sources like command line arguments, environment variables, local secrets, and even the cloud. All these configuration sources are automatically read for us and loaded into the configuration system during host startup, which is configured in the program.cs file in ASP.NET Core applications. And from there, we can get access to them typically in our startup.cs file. Let's now update our catalog service to take advantage of both dependency injection and the ASP.NET Core configuration system. In order to start using dependency injection in our microservice, we will need to start using interfaces as opposed to concrete types when constructing dependencies. Let's start by updating items repository so that it implements an interface that we can use in items controller. So let's go to our repositories directory, items repository. And then what we want to do is to extract the interface that represents items repository. And we can do that by clicking on items repository. And as you can see, there's this yellow light bulb over here. You can click on that one, and then you can click on extract interface. By doing that, as you can see, the full skeleton of the interface has been extracted out of the items repository class, and items repository is now implementing iItems repository, our new interface. We also want to have the interface living in its own file just to follow some good code organization across our microservice. What I'll do is I'll click on iItems repository, I'll click on the light bulb, and then I'll click on move type to iItems repository.cs. Now iItems repository lives in its own file over here on the left side, iItems repository in the same repositories directory. And so with that done, we are able to start doing dependency injection of items repository into the items controller. So I'll open the controllers directory. I'll go to items controller. I'll scroll up all the way to the start of the class. And I'll start by updating our items repository definition here so that we actually use items repository as opposed to item repository. And I will not create an instance right there. It is time to introduce a constructor for this controller. So I will do public items controller. And here's where we are going to inject the items repository dependency. So items repository. And here we'll just do this item repository equals item repository. So just by doing that, item repository has been injected into items controller. Now, the same way that we are doing this, we also want to use dependency injection in items repository itself. So let's go back to that file. Because we don't want to be constructing the Mongo client like we're doing it here. We want to just receive an instance of our Mongo database or iMongo database directly as a dependency injection. So what I'll do is I'll just declare in items repository an iMongo database object, and we'll say database. And with that, we will get rid of these two lines. So now items repository is ready to receive an instance of database via dependency injection. However, now that we have removed those lines, we need a way to actually construct this database object and configure it. So let's go into the configuration part of this now. To configure the host and the port that our service needs to connect to, what we can do is to declare these settings in our app settings.json file. So let's go to app settings.json. And here's the ideal place for you to declare these kind of configurations that could change with different environments. So what I'll do is I'll open up another section here. Let's call it MongoDB settings. So we'll open up a section. I'll put a comma also here. And then the first setting is going to be the host, which in our case, since we're running against a server in our local machine, is going to be just localhost. And the port is going to be 27017, the default port and the one that we've been using in our Docker container. We are also going to add another settings section to define our service name. This service name is going to be used across a few places in our microservice. So let's declare that just on top of MongoDB settings, we will name it, this section is going to be service settings. And we'll just declare one property here, which is going to be service name, which in our case, since this is the catalog service, we will just put the value of catalog. Okay, So now we have a setting for the service name and for the MongoDB host and port. Now the thing is, how do we consume these settings in our code base? So there's a couple of ways to do that, but I think the most straightforward way is to define a class that represents each of these two settings so that then our code base can start using them right away. So to do that, what I'm going to do is just right click on play.catalog service. I'll create a new folder that we're going to name settings. And in this folder, I'll declare classes for both service settings and MongoDB settings. Let's start with MongoDB settings actually. And I'm actually going to copy the name of the setting. So to make sure that the class that we create here matches exactly the name of MongoDB settings in there. So I right click, new file, MongoDB settings.cs. Let's declare a namespace. It's going to be play catalog service settings. And let's declare our class, MongoDB settings. And just as we just did, it should have properties for host and port. So let's declare prop string host and prop string port. Actually, this should be an integer. So prop import. And then, since we are not planning to change these settings after the microservice loads, we will switch from this setter from set to init. So that will prevent anybody on any piece of the code to modify the values after they have been initialized. Next, we're going to also declare another property, kind of a calculated property, that's going to define the connection string to MongoDB. So we're going to declare public string connection string, and we'll do a little bit of string interpolation here, where we're going to declare MongoDB, and that's going to have the host and port. So the host comes from our host property, and the port comes from our port property. Okay, so this is what we call an expression body definition. So it's a property defined directly by the value on the right side. Right, so we have a connection string there. The next thing we need to do is define a type class for service settings. So I'll copy the name of service settings here. And then again, I'll right click settings, new file, service settings.cs. Declare again namespace, catalog service settings, public class service settings. And the only property that we have for this one is a service name. So prop string service name. And again, this will be init. Now that we have all this defined, it's time to start constructing all these services, constructing and registering and constructing all these services that we'll be using for dependency injection, and also taking advantage of configuration. So to do that, we'll go to the startup.cs file, and I'm going to collapse this to get a bit more space so we can see. And the first thing that I'll do is I'll go to the top of the startup class, and I'll define a variable, a class level variable for our service settings, just because we will be using it in a few places across the subsequent lessons. So private service settings, and I'll have to do control dot to import play catalog service settings. All right, and then just before adding controllers, I'm going to open a section here where first we're going to retrieve the value of those service settings. So what we're going to do is service settings equals, and here's where we access the .NET configuration system, where we'll be at the configuration property that we have available right here at the top, configuration. So we're going to say, okay, so configuration, we're going to get section. So we want to get the section that has the name of our service settings class. So this is what we wanted to make sure that the class is named exactly as the name of the configuration. And when we have gotten that, we're going to turn it into the actual type. So we're going to say that get service settings. There. So with that, we are deserializing the value of service settings that has already been loaded into the .NET configuration system into this service settings variable here. The next thing we're going to do is to construct our MongoDB client. To do that, we're going to be using our services collection. So we will do services, which is we received in the as a parameter to configure services. We're going to say add singleton. Add singleton allows us to register a type or an object, and makes sure that there will be only one instance of this object across the entire microservice in this case. So any class that needs it will get this one instance so they can use it. So here we're going to receive the service provider. Okay, so now we'll open an expression here, and I'll close this with that. And just like we did with service settings, we're going to now define or retrieve our MongoDB settings. So I'm actually going to copy this section here, and we're going to say this is going to be MongoDB settings. Okay, so is configuration get section name of MongoDB settings, and then we will again convert it into the actual MongoDB settings type. Now that we have the settings, we are able to construct the Mongo client, which, like I said before, is the class that we need to use to actually connect to MongoDB. So we will say Mongo client is a new Mongo client, and I'll import MongoDB data driver here. And here, what we want to pass is the connection string. So to pass the connection string, we will do MongoDB settings dot connection string. And finally, now that we have the Mongo client, we can get the instance of the database object that we care about. So we will do return Mongo client get database. And then what's the name of our database? Well, the name of our database is going to be the one that we define for the service name. Service name is catalog. Our database will be just catalog. So service settings, that service name, and that's it. So with this section, we have defined a single object that represents an iMongo database that's going to be injected, as you remember, into items repository over here. Is going to be landing over here, iMongo database. So here's where we're constructing and registering it with the service container. And then one more thing that we need here is to also register the items repository dependency. So we're going to be doing services that add singleton, and then we will use our new items repository interface, and then I'll import the play catalog service repositories namespace, and then the concrete type is going to be items repository. Right. So this registration is a bit different than the previous one, because in the previous one we're explicitly constructing our Mongo client and the Mongo database before registering it with the service container. While in this case we're just declaring which is the type that we want to register and which interface it implements, and the ASP.NET Core runtime will take care of constructing that instance whenever it is needed. So we should be ready to try this out, but what I'll do is I'll place a few breakpoints so we can see how things start lighting up as they do. So I'll put a free breakpoint. So I'll put one over here. Then I'll go to items repository and I'll put one in the constructor over here. And I'll also go to our items controller and I'll put another breakpoint here. And now I'll hit F5. Okay, so we can go to our Swagger UI page. I'll go /Swagger. And of course, we don't have anything in our database right now, but regardless, our service will need to construct all these dependencies to be able to figure out that there's actually no items right now. So I'll open up our get all items operation. I'll click on try it out, and then I'll click on execute. Now back in VS Code, and I'll collapse this a bit. We are now in our startup file, And notice that right away we are entering into the add singleton section here. This is because so there is one or more services that need these iMongoDB objects. So if we inspect the value of MongoDB settings, we can see that we already have defined the host port, and the calculated connection string is right there. And that's what we are using to feed into the Mongo client connection string. We should also have a value for service name here from service settings, has been read from configuration, and it's been used to get the database that we're going to be using. This database will be constructed the first time, and the next time it will be just reused. So I'll hit continue here. And now we are into items repository, which now is able to retrieve that instance of the iMongo database object that has been constructed and it's been injected here. And it is via that one that is going to be able to retrieve the items collection that's going to be used across the items repository. Then I'll click continue. And now we are in the items controller, which is now able to receive that injected items repository that is going to also be used for all the operations. So I click continue, and we're back into Play Catalog service, the Swagger UI, which of course it says that there's no items right now, but we know we can easily go ahead and start creating items, updating items, and all these things with the Swagger UI. But yeah, so the dependency injection is configured and the configuration system is enabled too. So we have reached the end of this model with a fully working, decoupled, and configurable microservice that is able to store and query for our catalog items in a MongoDB database. In the next module, we will introduce our second microservice, and we'll be learning about the multiple challenges of having microservices talk to each other.